One developer kicked off an autonomous coding agent on a Friday. By Monday, the API bill sitting in his inbox read $4,200. The detail that matters here is that he didn't write $4,200 worth of prompts. He wrote exactly one. From that single prompt, the agent planned out a sequence of actions, called external tools, and went to work. When a step failed, it read the error, reasoned through the problem, and retried. It looped over and over, burning tokens the entire time. A bill this size is the direct mathematical output of how an autonomous agent functions. Avoiding that exact runaway financial risk is the entire reason engineers are desperately trying to run these models on hardware sitting on their own desks. True autonomy breaks the logic of predictable, single-prompt costs. I'm Bearded AI Guy, and welcome to day one of our new series, Poor Man's Spark. The foundational principles we're using to define how agents actually work are drawn directly from the human architect's best-selling book, AI Agents in Action. But the specific hardware data, the benchmarking, and the economic findings we're looking at today are brand new, independent research conducted by the human architect, entirely separate from the book. Almost every existing guide to building a local AI rig optimizes for one number: streaming tokens per second. Because agents operate in loops rather than linear streams, they completely break that traditional hardware playbook. Before we can build a proper local agent rig, we have to tear down the old benchmarks and establish an entirely new measuring stick. This graphic shows the structural difference. On the left, a standard chatbot workload, one straight request in, one answer out. On the right, an agent workload, a dense, infinitely repeating loop. That loop is the anatomy of autonomy. It plans, calls a tool, reads the result, reasons, and retries. According to a 2026 Gartner analysis, agentic tasks consume roughly 5 to 30 times the tokens of a single chatbot interaction. Every prompt fans out. That multiplying effect is the pressure driving enterprise teams to pull this massive loop onto hardware they physically own. There are 4 main operational drivers for this. The first 3 are absolute privacy for auditable infrastructure, legal compliance for healthcare and finance data, and offline resilience. The fourth driver is predictable cost. Self-hosting is the only mechanism that converts a runaway, infinitely variable loop into a flat, predictable hardware sunk cost. The largest professional misconception in local AI is the belief that peak tokens per second is the most vital metric for your hardware. Think of a standard chatbot workload like a kitchen cooking one massive banquet meal. Overall cruising speed is the only thing that matters. An agent workload is a short-order kitchen juggling dozens of tiny tickets. What matters is delivering the very first plate for each new ticket. Through a technical lens, multi-step reasoning inherently serializes the work. You cannot generate step 3 until step 2 finishes and the tool returns a result. Here are the 3 vital metrics for agents: time to first token, sustained throughput, and memory for growing context. Tool calls ruin streaming momentum. Standard inference sustains 6.4 queries per second, but React agents drop to 1.2 to 2.6. Focusing solely on peak streaming speed creates an architectural mismatch for agent-based workloads. This is why we use the NVIDIA DGX Spark as our ultimate measuring stick for local agent deployment. Despite its $4,699 price tag, the Spark does one specific architectural trick flawlessly. It shares a massive pool of memory between the processor and the graphics chip. Under the hood is the GB10 Grace Blackwell superchip, a 20-core ARM processor paired with 6,144 CUDA cores, pushing 1 petaflop of FP4 performance. Its defining feature is 128 gigabytes of coherent unified memory, bypassing traditional VRAM limits entirely. That massive memory pool is exactly what allows edge hardware to run large 200 billion parameter reasoning models locally. And this hardware is a moving target. It saw a 2.5 times performance gain simply from CES 2026 software updates on the exact same silicon. The goal of the Poor Man's Spark rig isn't to beat this superchip on pure compute. The goal is to cheaply replicate its massive shared memory architecture. This table breaks down the math on a baseline scenario, an always-on personal agent running at a moderate volume of 5 million tokens a day. A hosted API costs $295 monthly, forever. The $1,500 Strix Halo rig replicates the unified memory trick, paying for itself in 5 to 6 months. The premium DGX Spark takes 16 months to pay off. The financial advantage of local hardware depends entirely on 4 critical words: at this duty cycle. Now, the honest counter-argument against local hardware. Think of this like renting a car. Renting a cloud GPU is like renting a car hourly. If it sits idle in your driveway, you pay full freight for 0 mileage. This visual illustrates the utilization trap. Running a rented GPU at only 10% load mathematically inflates your effective cost per token by roughly 10 times. A local rig's sunk cost is low. The penalty for sitting idle is just pennies of electricity. Industry analyses completely disagree on where owning beats renting, ranging from 2 to 3 million up to 360 million tokens daily. These sources disagree because they assume entirely different utilization rates for the hardware. We have to acknowledge that managed cloud services are getting faster and cheaper, offering sub-half-second time to first token, and occasionally beating self-hosting costs by up to 90%. Optimal performance usually comes from a hybrid approach, dictated entirely by how heavily the system is loaded. The human architect's research points to one central finding: selecting hardware is a matter of workload alignment. Agent loops demand rapid time to first token and massive context memory, which both the Spark and the Halo rigs solve via a unified architecture. Economically, owning these rigs only mathematically beats renting if your actual daily usage justifies the hardware. That gives us the definitive mental model you must adopt before attempting to build a local AI rig. Measure your duty cycle first, then pick the box that fits the loop. That concludes day 1. We've established the ultimate measuring stick for the rest of the builds in this series. Make sure to subscribe to Bearded AI Guy so you are notified when the actual physical rig build begins in the next episode. Let me know in the comments, what is your real-world duty cycle estimate, and are you betting on owning or renting? A quick reminder, while this local hardware research is the human architect's independent work, it builds directly upon the groundwork established in their book, AI Agents in Action. Agents mean repeating the same tasks, with massive token counts, constant round trips, and exploding contexts. Match your hardware to that reality.